Hello students, welcome to another exciting lesson in science. Today, we're diving into a fascinating topic, work and energy. These are concepts that we encounter every day, even if we don't always realize it. Have you ever noticed how you get tired after playing, running, or lifting objects? These activities are not just fun, they are also examples of work and energy in action. That's because you're using energy, and you're doing work. Your body is like a machine that needs energy to function. Let's understand these concepts more clearly. By the end of this lesson, you'll be able to identify work and energy in your daily activities. So what is work? It's a term we use often, but in science, it has a very specific meaning. In science, work is defined as the process of a force causing an object to move in the direction of the force. We say work is done when a force causes an object to move in the direction of the force. This means that both force and movement are essential for work to be done. For example, if you push a chair and it moves, you've done work. The chair's movement is the result of the force you applied. But if you push a wall and it doesn't move, no work has been done, even though you used energy. The wall didn't move, so no work was accomplished. Here's a simple formula to remember. Work equals force times distance. This formula helps us calculate the amount of work done. The unit of work is the joule, symbolized by the letter J. This unit is named after the scientist James Prescott Joule. The joule is a standard unit of measurement in science, used to quantify the amount of work done or energy used. Now there are two types of work, positive work and negative work. Positive work occurs when the force and motion are in the same direction. For instance, pushing a car forward. And negative work happens when the force and motion are in opposite directions, like when you try to stop a moving object. Understanding these types of work helps us see how forces interact with objects in different ways. Now, let's talk about energy. Energy is a fundamental concept in science and is essential for all activities. Energy is the ability to do work. Without energy, nothing would move or change. Everything we do, running, cooking, thinking, requires energy. Our bodies and the world around us are constantly using and transforming energy. And just like work, the unit of energy is also the joule, J. This shows the close relationship between work and energy. There are different types of energy, each playing a unique role in our daily lives. First, we have kinetic energy, which is the energy of moving objects. This type of energy is all about motion. Think about a rolling ball or a flying airplane. Both are examples of kinetic energy in action. Then there's potential energy, which is the stored energy in an object because of its position. This energy has the potential to do work. Imagine a book on a shelf or water behind a dam. Both have potential energy due to their positions. One important principle to remember is the law of conservation of energy. This is a fundamental concept in physics. This means energy can neither be created nor destroyed, but it can change forms. For example, chemical energy in a battery can become electrical energy. Now let's look at some daily life examples of work and energy. These examples will help you see how these concepts apply to your everyday activities. When you lift your school bag, that's work done by your muscles. Your muscles use energy to lift the bag. Riding a bicycle involves kinetic energy. The movement of the bicycle is due to the kinetic energy you generate by pedaling. And using a battery-operated device is a great example of chemical energy changing to electrical energy. The battery stores chemical energy, which is converted to electrical energy to power the device. Work and energy are all around us. They are involved in everything we do, from simple tasks to complex activities. Understanding them helps us see how we use energy in everything we do. It also helps us appreciate the science behind our daily activities. Keep observing where work and energy appear in your daily life. You'll be surprised at how often you encounter these concepts. Thanks for watching, and keep learning. Remember, science is all around us, and there's always something new to discover.